All right, welcome everybody to, again, the Cal Poly ME Open House Day. Again, this is a bit different than what we were all expecting even a few weeks ago. And so this kind of got thrown together at the last minute, but just popping into the last session, it looked like things are going well. And hopefully everybody is enjoying getting to know Cal Poly and the ME department a little bit more before hopefully coming here in the fall. My name is Richard Emberley. I'm a professor here. I've been an ME professor for 3 years now. My areas are in thermal fluids as well as in fire protection engineering. So if you have any questions about that, I'd be happy to go into that. But I am here as a moderator, and you don't want to hear too much from me, but you do want to hear from Sylvia, Michael, Sam, and Zoe, and about their careers, internships, graduate school, and things like that. So what I'm going to do, just like on the first session and the main session, you have a kind of a Q&A tab there. And so what I will do is, as we'll turn it over to all the various panelists, then I will try to do my best to answer any of the questions and answers, things that come up. And then if we have time at the end, then we'll do our best to kind of work our way through some of those and allow them. So what I will do is again, we have this here for several of the presenters. And so what we'll do is we're just kind of work our way through. And so we will start first with Sylvia. So Sylvia, go on ahead. I'm not sure if you have the ability to change the slides, but if not, just give me a nod or say next slide and I'll jump forward with those.
I don't believe I do. So I think I'll just be saying next slide or pause.
All right. Well, we'll go with that then. So first slide here.
Well, welcome everybody. Before I get started, I just wanted to say congratulations on getting accepted to Cal Poly. That is such an achievement. So I'm really excited that you are considering Cal Poly, and hopefully we're here to convince you to come to our school. My name is Sylvia Mora. I'm a mechanical design engineer, and I graduated from Cal Poly in 2013 with a bachelor's in ME. Then I went on to work full-time for Lam Research, and at the same time I got a master's degree in engineering management from Santa Clara University. Then after 6 years, I left Lam Research, and I'm currently at a startup called Zoox, and Zoox is in the autonomous vehicle industry. Next slide, please. So I wanted to start off by telling you why I personally chose Cal Poly. The learn by doing is something that you're going to hear over and over and over again. It's both our motto, but it's actually more of a lifestyle, and that really matched my learning style, which is one of the reasons why I chose to come here. Once I walked around campus, saw the labs, saw the hands-on projects, saw that they had machine shops and students were running the machine shops and also participating in the machine shops, I knew that that was going to fit well with my learning style. Also, the majority of the professors at Cal Poly at one point worked in industry and bring that knowledge to the classroom. Probably one of my biggest frustrations of my master's degree is that most of my professors were very theoretical. And every time a concept was introduced, I would raise my hand and ask how it's applicable to the real world or in practical terms. And it was difficult for them to answer that. And that's not true at Cal Poly. Everything that you're learning is very applicable and is very practical. Cal Poly is one of the few schools that forces you to pick a major before you start your college experience. And the reason for that is because from day one on campus, you're taking major classes. So that sets you on a roadway and a pathway to start learning and learn by doing in your major right away. It's not just GE classes for the first 2 years. Another big reason why I chose Cal Poly is Cal Poly is centered in San Luis Obispo, which is a small town. So it's a college in a small town as opposed to, for example, the Bay Area or LA area, where it's a huge city and you may find your college within that big city. Now, the reason why that matters is because you have an abundance of access to your professors. If you live in the Bay Area and you're taking classes in the Bay Area, you'll find that most of your professors also work full time, so they're rushing in and out of the classroom. Versus at Cal Poly, you can find them biking around campus, you can bump into them at the grocery store, and that really makes a different experience. Lastly, when I walked around campus and I came to in-house, I found a place that I saw myself being a part of. So the community there was something that I envisioned myself contributing to and merging well with. Next slide, please. So at Cal Poly, I did a couple different things. I played on the Cal Poly club volleyball team for my freshman year. I was part of a fight team on a Muay Thai club or Muay Thai gym that was off campus. I ran multiple half marathons. I participated in projects. The picture right there with my teammates is our senior project, which is a 1-year compilation project from start to finish, design, build, and manufacture. And I had a little bit of a different experience at Cal Poly because while I was there, I was undocumented. So I was sitting under the DACA program. And being undocumented meant that I couldn't have any internships. So I had to get really clever about coming up with skills that I could attain that would be applicable to a job without having internships. So what I did was I did multiple clubs. I was part of various different engineering clubs, and I also ran and served on the student government there at Cal Poly. And again, I couldn't do internships, so what I did was I had different side jobs, babysitting for cash, cleaning houses for cash, and volunteering as a student assistant in order to get more work experience. Next slide, please. So when it's all said and done, here's what Cal Poly did for me. First, it embedded in me the teamwork and collaboration skill. Everything you do at Cal Poly is in teams. There is no siloed work. Cal Poly is very practical and hands-on, and you cannot survive that education without working on a team. It just will not happen. Every single course is designed for you to work in teams, and that's extremely valuable in industry. Another thing that it taught me is commitment. I have a quote right here. Commitment is doing what you said you would do long after the mood you set it in has left. Now, it is true that business majors don't have classes on Friday, and sometimes there's temptations like the beach, and there's a lot of fun things to do on campus, but you have to have that commitment to study and get your work done and hit your deadlines. Another large thing that I walked away from Cal Poly is learning how to face and conquer my fear. At Cal Poly, you have such various activities that you can be involved in, and you learn to not be fearful of something that you've never done or tried before, because it's an environment where it's safe to fail, and it's encouraged to fail and fail often so that you gain more experience. So once I conquered that, now I look at things differently, and that's where the grab the bull by the horns picture comes into play. And I took that with me in industry, and it worked really, really well. Last but not least, the last skill that I learned or took from Cal Poly is oftentimes you start off with a design problem, and you know where you want to go or what criteria the solution has to meet, but you don't really know how to get there. And it's not always a linear process. Sometimes it could be very circular, like you see there, and sometimes you feel oftentimes, on the path to B from A. But it teaches you that critical thinking skills of knowing where you are and knowing where you want to get, and just trying different things to get there. Next slide. So I wanted to share this with you. This is attributes employers seek on a candidate's resume, and it's from 2019. And I wanted to highlight, I think my bracket there missed my first one. Almost 70% of these skills I walked away from Cal Poly having earned one way or another. So ability to work in a team, that's number 3. Problem solving skills, that's number 2. That's the A to B. Communication skills, very much so when you write all your labs and the way that you do your homework, specifying out your different problems. Initiative, analytical, quantitative skills. So almost 70% of these skills, which is what employers are looking for, I walked away from Cal Poly learning. Next slide, please. Okay, so let's talk about a little bit of the real world. So taking all these skills with me and applying them to the real world. We'll start with the picture on the left. The picture on the left is one of the main projects that I began working on when I started my career at Lam Research. And here you see me in the lab. Because Cal Poly's learn by doing, after I had done my design work and all the parts had come in-house, I helped build this thing from the ground up with the technicians. Now, it's not normal to find engineers turning wrenches in the lab during a build, because that's what we have technicians for. But if you want to learn how you can make your design better, this is absolutely the best way to do it. To be there alongside the technicians, learning the flaws of your design, and if you had to do it again, how to make it better. The picture right here, second from the left, is me at a customer site installing my own equipment that I had designed. Again, the learn by doing there, where I insisted that I go to the customer site and install my hardware. The teamwork, the third picture, where I'm pulling my hair there, this is me in Japan working with our Japanese supplier on solving various issues that we had encountered with the design. So the communication skills, the teamwork skills, And this was extra difficult because of the language barrier, but just taking the initiative to try to explain things differently and work alongside world teams, really. The last picture right here on the right is me failing. This is me trying to figure out a system architecture of an entire system, and I'm a mechanical engineer. So that was really not my skill, but I learned along the way. And I failed and failed and failed until I got it. And these are all learned by doing in action within the semiconductor industry. Next slide. So in my current role, and I apologize for the pictures because I couldn't put any personal pictures since we're still a startup and haven't released our vehicle. Zoox is in the autonomous vehicle industry, and what I specifically do there is I'm in charge for the mechanical packaging of all the cameras. The cameras are very important because, as you can see in all these pictures, the camera poses a picture in order for our AI to make decisions on what's a person, what's a car, and based on that, it makes decisions on how the vehicle should behave. So jumping from the semiconductor industry to the autonomous vehicle industry, I knew nothing about the autonomous vehicle. And it was one of those things that was kind of a fear of mine to jump into something that I didn't know. But again, I knew that I walked away with all those Cal Poly skills. I knew I could take the bull by the horn, and I did it. And most importantly, the Cal Poly taught me how to learn. So I'm learning along the way, and so far so good. Now I get to work on autonomous vehicles, which is really, really, really exciting. And I think that was my last slide. Yeah, so in short, I hope I was able to convey some of the skills that Cal Poly will teach you and how that's directly translatable to the industry on any career that you may choose.
All right, thank you very much, Sylvia. All right, we're just going to keep going through. Again, I got some questions that are popping in, so please keep those coming. But what we're going to do is we're going to turn this over to Michael. So Michael, take it away.
Thank you, guys. Thanks for having me. My name is Michael. I'm
Hey, Michael. You're
Grad and last week that I completed the master's program. Can you hear me?
Michael, your connection's breaking up a little bit. It got a bit better towards the end, but it was breaking up a wee bit.
If you want, I could try reconnecting back on my other computer and you get me real quick and come back.
Yeah, why don't we give it a go? That Michael, let's jump to Sam, and then we'll see if we can get you back on there. Okay. So I'm going to jump forward, Sam. I'll jump you into here. So we'll do a bit of a switch. But Sam, take it away.
Sure. Hey guys, so I'm one of the older mechanical engineering students in the program. Not that old, but at Cal Poly, your thesis can be what you make of it. Let's not do next slide. There might be some embedded timings into it.
Ah, okay.
If you go to the top of your PowerPoint, sorry guys, we're gonna do this on the fly, learn by doing. Can you do that, Dr. Emberly?
You want me to just pause the timer?
Yeah, well, yeah. So yeah, if you pause the timer, you should be able to either delete them in the slide layout.
Yeah, timer should be paused now. Yep.
Okay, perfect. Okay, so at Cal Poly, like I was saying, your thesis is what you make it. I chose to go extremely in depth with my thesis, and so to most professors, we don't offer a PhD program, but this is around like a PhD level thesis. And I guess I mentioned that in that this is like a springboard for my PhD. I'll be applying for programs next year, and we'll get into it. Basically what I did was I worked with a large corporation in partnership with a professor down at UCSB to develop what are called structure property models for viscoelastic foams. And so basically you've got the macroscopic properties of the foam being its relative density or its elastic modulus or some kind of damping characteristic, because these are time-dependent materials. And then you kind of fold that into a, can you guys see my mouse?
No.
No? Oh, okay. Well, then in the lower picture, you can kind of see like a model unit cell. And so we kind of idealized the geometry. In the left-hand side, you can see what looks like a beam. If you guys have had, well, you guys are all grad students, and so you've seen elementary beam theory. And so using kind of large deflection beam theory, we got the curves on the right, which is kind of like a, this is novel in terms of the ability to predict the nonlinear response of a viscoelastic foam so quickly. Normally, a dynamic, fully explicit FEA model is needed. And so this research is really cutting edge, and hopefully we look to publish. And so you can definitely publish in established research journals cutting edge work from whatever you do from your thesis. And so next slide, Dr. Emberley. And so it kind of starts immediately, but actually I developed just like, can you, is there a way for you to like restart the video? Maybe not, is it loading? So basically what's going on there is that I developed a very simple apparatus in the machine shop, just CNC machined it, and took a sequence of images inside what's called an SEM, or a scanning electron microscope. I think you might have the timings. Anyway, and basically what this does is it gives us a better idea of what's actually going on in the foams. And so we were able to kind of calibrate our model to actually tracking certain points in these pictures and looking at cell strain. And as you can tell, it's extremely inhomogeneous. There's lots of pockets. And so we're hoping that by increasing the complexity of our model, we can actually capture some of those heterogeneities. But just, you know, going even deeper than it was probably required, but it's as deep as you want to go. And so next slide, Dr. Emberley. Furthermore, there was a lot of interdepartmental collaboration. I worked with some great engineers in the IT department, some mechanical engineers or technicians in the machine shops, which without them, there's no way I would have gotten to do everything I got to do. So I got to have access to like their aluminum, and they actually taught me how to like use the CAD programs. And so for developing a dynamic impact tester, which you guys will see on the next slide, I got to do all that by myself, which I don't think at almost any other university you would get that opportunity throughout your thesis. And so let's actually see it, Dr. Emberley, on the next slide, and hopefully it'll play. And sorry if it's a little bit.
You want it played?
Yeah. Go ahead and play it. Basically what's going on there, you don't have to play it again, is that I'm looking at the foam under cyclic fatigue. And so that thing will run for like thousands of cycles in order to get like a change in the stress strain curve as a function of number of cycles. And so that would be useful for, let's say, walking shoes, which wouldn't be related to my sponsor at all, but they probably are. And so a lot of cool projects, a lot of opportunities for interdepartmental communication and like machining, hands-on work. Really, as far as you guys want to take your thesis, you can go. And so, but aside from that, and on the next slide, there are a lot of great research opportunities within the mechanical engineering program if you choose to seek them out. So I've been privileged enough to work with Dr. Stephen Klisch in the Human Motion Biomechanics Lab. And I specialized in, it's still got those timings on, Dr. Emberley. I specialized in trying to take motion analysis data that we had from a camera array, filter that data, and then try to look at the way that people were moving based on, or try to identify differences in different groups of people. And so what I did was a series of gait experiments. You can see in that top right left picture, sorry, we basically put a cluster of markers on a person's body segments. Yeah, and Dr. Emberley is showing that right there. And we were able to put these clusters of markers on both the thigh and the shank. And through some bunch of math, you can get an idealized rotation tensor for each body segment. And then from those idealized rotation tensors, you convert them back you compute the angles about certain axes in the knee, and you can get what are called knee angles. And so I've listed those in the third bullet on the left. It's called flexion extension, adduction abduction, and internal external rotation. And basically those knee angles give us a metric for the health of certain participants. And so next slide, Dr. Emberley. And this is what I think they'd probably want to see the most. So I looked at several different kinds of participants. The first group that I was looking at was transtibial amputees. And so we, from a grant from the Army, got funded to look at the differences in knee kinematics. Sorry, don't know why. Pardon me, guys. To look at differences in knee kinematics between control subjects and transtibial amputees. And what we were able to show in this particular study was that in gait, there were significant differences between the biomechanics of transtibial amputees and control subjects, while in cycling, there were no significant differences, which makes sense because cycling is a much more constrained exercise, but it's also one in which you don't have a lot of impact. And so the abnormalities that you would normally see in gait from the transtibial amputee having an actual prosthetic kind of get eliminated. And so if you so choose, there are a lot of different kind of research opportunities, particularly in the human motion biomechanics lab, where if you want to blend mechanical engineering with perhaps a more biomedical engineering emphasis, it's possible. And so you can go on to the next slide. These are just more results, but we've done studies on a bunch of different participants and a bunch of different exercises. So this particular study looked at normal weight, overweight, and obese subjects, but we've also done studies that looked at ACL reconstruction patients. And, but our research isn't just limited to gait and cycling. We've got projects that would be great for people who are interested in pitching. And so if you're interested in pitching and want to look at pitching biomechanics and differences in the way that the shoulder torque is generated based on weight, those are definitely opportunities if you want to go that route. And so that's about all I had to say, Dr. Emberley.
I was unmuted. All right, we'll go back to Michael and see if audio is working. Go ahead, Michael.
Can you hear me now? If not,
Perfect.
Perfect.
Sounds great.
Okay, sweet. Wow, it works for once. Okay, so like I was saying before, my name is Michael Petralia. I'm a fourth-year undergrad mechanical engineering student at Cal Poly. And actually, as of last week, I found out that I got accepted into the blended master's program for mechanical engineering too. So I'll be back for another year. Excited about that, but I'm here to talk a little bit about my internship experience, particularly last summer at Aerojet Rocketdyne, which is an aerospace company. They're located all throughout the nation, but the office that I worked in was in the LA area in Canoga Park. And so they're a defense and space company specializing in thrusters, the production. So the top photo that you see there is actually one of their thruster testings. That's a hot fire test is going on right there. Sadly, I was not present for that one, but it was going on when I was working there. And then the second picture, the bottom picture, is actually the unit that my manufacturing internship was focused on. And I'm a general concentration at Cal Poly, but the position itself was manufacturing. So that was a little bit different for me, a chance for me to kind of explore my options, especially as a general concentration, keeping my options open right now for what industry I'd like to go into. So next slide, please. So some of my responsibilities here as an intern, and there's only a couple of photos I actually have from my internship because we did have an NDA. We are government contracted, and so a big thing was not having camera use unless you were certified. And I was an intern, so I didn't quite have that responsibility, but I did get some last day photos. So pictured here on the right is me with the power head for the RS-25 thruster, which is one of, I guess, it's one of their main engines they've been making. They've been making these for years. The RS-25 engine is actually the engine that was used for the moon mission all those years ago. So a big thing that happened at the company last summer was they were celebrating their 50th anniversary of the moon landing. And so that was a big exciting time to be a part of that specifically, and seeing all the components being produced in-house. In this picture, I'm also standing in our main machine shop, which is where both our defense and space side components are produced. So pretty much everything we do for the main thruster components are done in-house. So as an engineering intern, specifically, I was working on the DAX unit, which is that picture from the last slide. That's the Divert Attitude Control System thruster. And those were actually put in interceptor missiles that the Department of Defense uses for their THAAD mission, which is Terminal High Altitude Area Defense. A lot of acronyms I've learned from working there. And it was honestly really cool to see. We only do one part of the interceptor missile. We focus on the thrusters. And so everything that we were working on centered around that on the defense side. And a lot of what I was doing was focusing on the actual timing of these projects. So whether it was rewriting production schedules, which was kind of more side work, or working on larger tooling assignments. The largest project that I had over the summer was actually redesigning some of the tooling that they were using for one of their manufacturing processes for the manifold that holds on all the thrusters. And so there are 10 total thrusters on this thing, and the manifold that I was doing the machining for held 4 of them. So I got to work a lot with CAD, which I had plenty of experience from working at Cal Poly with CAD, and learning some new software and working with designers to do that. So even though I was doing manufacturing engineering, I wasn't really pigeonholed into a manufacturing experience, which is really cool. And something that I guess was really cool too was the other side of my projects were working with nonconformance committees on this process, because it's such a critical process. Everything that's done, all the manufacturing and like welding that's done is done in the clean room. So the particle count in the air has to be extremely low. They've talked about instances where someone had too much cologne on, and that was enough to be a hazard for the safety of everyone there. So that was pretty interesting to see how clean and how everything had to be really particular in order whenever you went in the clean room to take care of business in there. But I also worked with the nonconformance committees if there were any issues, because they were producing a lot of these units, to make sure that we could correct those issues quickly. So something that I thought was cool while I'm on this slide too, with my responsibilities, there was a lot of transfer from what Cal Poly was doing to what I was doing in the shops and in the design work. And so I mentioned before I was using a lot of CAD. When we work at Cal Poly, we work with SolidWorks primarily. And that's where we do all of our drawings, all of our 3D modeling, FEA we can even do in there. When I got to work here, they use Creo, which is a different 3D modeling software, same general idea, but something that was really cool about Cal Poly is when they're teaching you how to use SolidWorks, for instance. I had no experience going in. I had the opportunity to understand why the programming and the coding that goes into making the software work and the drawings work, how it was possible. So when I got to my internship, it was actually relatively easy for me to pick up a completely new program that I hadn't used before because of that prior experience. So I thought that was pretty cool to work with. And then just in general, the collaboration that you have to work with a lot of your labs, has been mentioned before, is honestly huge, because all the people that I was working with within the industry were people that had been in the industry for a while. And as an intern, I wanted to come in and not feel like I was an intern that didn't really know what was going on, and I could contribute right away. And I felt like I could contribute right away because they were asking for my input, and I was able to communicate the information that I needed to get to them very clearly. So Cal Poly prepped me really well for these responsibilities that they put on me specifically. So if you go to the next slide, I'll get into more about the internship experience. So this is more for the internship program as a whole. I think something that's really cool is, every company has a very different internship program, and some, that are larger, like Aerojet, where it's kind of a more national company, they have a lot of interns scattered throughout, and so they find ways to get the interns connected. And I think this is it's not really necessarily a pitch for my company, but it's something pretty cool that I got out of the internship experience that I hope that other companies would get to show you. And so that started with the weekly meetings with my fellow interns. And so even though I was in the defense side of things and the manufacturing more specifically, there were about 50 interns at my location, scattered throughout different departments. Some were electrical engineering, most were mechanical, some were aerospace, some were even on the business side of things, but they made sure to keep all of your interns connected. So And then that brings me to the next, the picture on the top, which is the LA Aerospace Games. If you're ever working for an LA Aerospace company, something that they offer in about the middle of the summer for the internship is the Aerospace Games. And all the, as least as many as I can think of, aerospace companies around the LA area gather, and it's just basically a bunch of you know, beach events. There's volleyball and soccer, and you know, the main takeaway obviously is a super fun day, but you get to see how many people, especially how many interns are, you know, working relatively close to you on completely different things. So engineering has a lot of opportunities in the LA area and big areas in general, but this was something that was really cool for me to experience. And then if you look at the bottom picture, it's actually not my group that was there, but that's the same location that we held our intern day in Huntsville, Alabama, which is known as the Rocket City for a lot of aerospace companies. And pictured there actually is we were in the Kennedy Space Center, I believe it's, and basically this was where we had our like final culminating event. But something that was really cool was we got to tour a lot of the facilities from other buildings that Aerojet hosted, and this is one of their major buildings that they don't use for any research or anything like that, but they use it as an educational opportunity for people to come see kind of what space travel is all about, and that space design is all about. And then the last major point for my programming experience was getting a chance to actually talk with and interview the CEO. Something that was really cool about our internship experience in general was that higher up people in the company were very accessible and super willing to talk to you. And so there were actually two instances where our CEO made herself available, one to all of the interns, and then a second time to a select group of us from our LA location to go down to El Segundo where their corporate office was held, and ask her, and then actually one of the stakeholders in the company who was a primary investor, just about the direction of the company and understanding really what the major goals for the company are, which I think are, it was pretty cool just to be in that environment and, you know, as an intern, be able to see where someone who was in my shoes, whether it was, you know, 20, 30 years ago, can kind of work themselves up into that position. So that was another really exciting experience, and definitely overall, all these different events helped shape my intern experience and really get me excited about the company as well. So if you go to the next slide, again, my takeaways. So this is me pictured with the completed RS-25 thrusters. And again, these have been in production forever. So this was, they whip these out like they're fresh baked cookies, I swear. So my major takeaways though from this internship experience were, one, of course, the connections that you build. Internships, you always want to aim for connections. That's how a primary way that I got my internship was, you know, with connections and making those calls and going to career fairs, especially those. That was huge for me, as Aerojet was present at all those career fairs. So the connections are huge, but I don't mean that just as like building your network kind of a thing. It also really helped for when I was trying to gain experience, because a lot of these people had been in industry for so long and had been working together for so long that they knew the ins and the outs of the systems. And I thought that was really cool. And one thing with that experience too was being a manufacturing engineering intern. I got to work both with the design side of things, and I got to go actually into the machine shops, talk with machinists, ask them, you know, why is this thing on this drawing need to be a certain way? You know, why is this distance so critical? And kind of understand the nuances of what we were actually creating. So it wasn't just a top level understanding of it. I actually understood everything from the drawing to the actual production and to the final result with what we got from there, which was super cool. And then, you know, I also, for me, one of the reasons I stayed as a general concentration mechanical engineer was because I really didn't know what industry I wanted to go to. I just knew that I enjoyed what I was studying, and I didn't really have an idea of how that would apply until I got into this internship. And so this was a real motivating factor for me. I think that you can do with a lot of companies a lot of the same things between companies, but have completely different products that you're creating. So one thing that I would also say as a word of advice is, when you do find an internship that you're considering, think about what they're making, what their kind of goals are as a company, and see if that really gets you excited about it. I I wasn't someone that like dreamed of like going into space one day or being an astronaut or anything like that. But I still found, you know, when I got here that it was really, really exciting work. It was groundbreaking work a lot of the time. And that's, I think, what was a big motivating factor to keep me going. And a big reason why I think I'm in mechanical engineering in general. A lot of the classes I'm taking are, of course, you know, very difficult. We all have to take these classes. But I think if you don't have that enjoyment and appreciation for what you're doing and that like aha moment, that it doesn't really make it as worthwhile. So I definitely encourage you to find that purpose and that motivation. And, you know, this internship was really, really good to me in that way. So. And yeah, that's about it. Oh, the other thing I was going to say is we had 55 interns, I think, at our location, and 12 of them were Cal Poly students, which is not a coincidence by any means. And a lot of the Cal Poly students that were there were MEs that I take classes with. They're, you know, fourth years now, or that were grad students and that I knew. So building those relationships and being able to share those experiences with them is also a really important part. And it's also really cool to see how desirable Cal Poly is for internships.
All right, thanks, Michael. All right, without further ado, Zoe, take it away.
So I'm going to give you the Cliff Notes version because we have about like 2 minutes left. But I just wanted to say really quick congratulations to everyone again on getting into Cal Poly. I know that this is such an exciting time, and the excitement is definitely well deserved because it's a big accomplishment to get in. I'm a 5th year mechanical engineering student here at Cal Poly with a concentration in mechatronics, and I'm here to tell you about my internship at Maxar. So next slide, please, Dr. Embley. So Maxar has a couple of different branches. The one I worked for specifically is called Space Infrastructure, formerly Space Systems Loral. And this is the branch that does all the design, build, and test for satellites and other spacecraft. So here I've pictured a picture from Maxar's website because similar to Michael, we weren't actually allowed to take many pictures. But this is from Maxar's website of their high bay, which is where most of the build actually takes place. And then just to give you an idea of who Maxar is working with, some of their customers include Sirius XM Radio and NASA, but in total they have built over 300 satellites, including both geostationary orbit and low Earth orbit satellites. And then they're sort of venturing out into new types of spacecrafts for NASA. So things including Restore-L, which is essentially like a gas station in space, and the power propulsion element for the Lunar Gateway are sort of on the horizon for them. Next slide, please. So I wanted to briefly discuss getting the internship and talk about sort of Cal Poly's role in helping me to get this internship. So there's a lot of great resources here at Cal Poly for you to land your dream job. For me, I attended an info session here on campus for Maxar, which is basically just gives you the opportunity to learn about a specific company before you actually have to go network with them. And then after that, I went to Cal Poly's career fair, which you may have heard in the main session is just a huge networking session with a ton of really awesome employers. So I actually talked to Maxar at the career fair and then got an on-campus interview with them later. And then I had 2 phone interviews and then I was hired. So that was a great resource, but then also you have even more resources like career services to build up your resume and prep you for your interviews. And then of course your amazing ME professors. I know one time I was really stressed out for a technical interview that I had, so I emailed one of my professors, and she actually took 2 hours out of her day to go through some questions that she thought they might ask me to help me feel more confident in my interview. So a lot of really amazing resources that helped me to get this position. Next slide, please. So my actual intern experience, I was in the systems engineering group. So basically my projects included doing documentation of processes for the research and development teams. So One of them being how a new product is getting inserted into the product line. And then the other being a technology roadmap, which is basically where the technology is going to advance for the company in like the next 5, 10, 15 years. And then I also got to sort of roadshow all of this to a lot of people in the company, which helped me to develop my communication skills and also helped me to make a lot of really awesome connections. There was also a ton of awesome intern activities that they had set up for us. These included things like workshops and classes. So from things like transitioning from school to your full-time job to classes on orbital dynamics. So like a really broad range there. And then we also had a ton of social activities. And similar to Michael, there was a ton of Cal Poly students and Cal Poly interns and full-times at Maxar. So I felt right at home there. Another thing we got to do was the hackathon, which is basically didn't involve any coding, but was a problem-solving challenge for us. So we had 2 weeks to come up with a response to the concept of operations for getting supplies to the Lunar Gateway. So we developed that and then were able to present it to people in the company. So that was a lot of fun. And then the last thing that I found really valuable was having engineering buddies. So that was someone who was a full-time engineer at my company, but that connected with me so I could sort of discuss with them things that I think, questions that I had, and I felt a little more comfortable with them just because I knew they were like more recently in my shoes. Next slide, please. So some other things included doing tours of all the facilities, like the one that I showed a few slides back of the high bay. And it was really awesome. I actually got to take my family in to do a tour of the facilities. So that's why there's a picture of me and my little brother there. They were super excited because, again, I couldn't take any pictures of anything. So they were super happy to actually be able to see what I was working on. We also had launch viewing parties, which were a ton of fun. Basically a celebration every time a satellite was sent into orbit. I did shadowing and informational interviews with other employees, and that actually worked out really well for me because one of the people I did an informational interview with is my future boss for when I return there in August, who of course also went to Cal Poly. And then the last thing is we would go out to lunch as people working at Maxar that were going to or had gone to Cal Poly. So again, that Cal Poly network was super strong even at this company. So I think that's pretty much all I have. Thank you very much.
All right, so we are now 4 minutes past what I thought was going to be the hard deadline. So maybe while we were talking, they were working on the glitch and got people off the thing. So what I'll do right now, I've been answering a few questions here, but if anyone has any questions, feel free to jump in there. If any of our panelists have any final thoughts they want to add in from anything else, please feel free to unmute yourself and do that. And so we'll give everyone a few minutes. I will leave this from a thank you to all of us. I'll leave it here. If you do want to jump off while we're kind of answering a few questions and things like that, and go to a Q&A with the department chair, again, please log on to the me.calpoly.edu/OH-2020, all right? So where you got from here, and you can follow the link to that breakout session. So we'll stay on for a few more minutes if you have any questions or if anyone has any final comments. What I'll do is I'll just wait until there's awkward silence and then we'll end it. Michael, go ahead if you have anything.
I would like to say that I was looking at some of these questions too. And for me, my first internship was last summer. So between my third and fourth years, I know some people do it earlier, some people do it later at all. I think that one big worry is that there are so many jobs out there, like how do I find the right one? One, I recommend the career fair is a fantastic opportunity to meet companies. I went, even as a freshman, when you're not necessarily as desirable as an intern to be hired because you don't have that experience yet, it's still very valuable to go to these career fairs, interact with a lot of the interviewers and the employees that come and take out their time. A lot of the time they're Cal Poly grads too, so I think it's a really good opportunity. I went to Aerojet both before and after I had interned there to their career fair booth just to see who it was, and it happened to be the same guy, Cal Poly grad there. So it's super important, I think, to get out and at least put yourself out there early and make yourself visible to companies. Whether you get an internship right away, I think is less important than some people try to push it, in my opinion. Other people can have other opinions, of course. And also I'm not an outstanding like 4.0 student by any means. I'm not, a super low level student either, I would say, but I think that you don't have to have the most ridiculous grades to get in to these internships. A lot of what they look for is your practical experience. And so if you have some sort of passion or project that you think really can tie into the job that you're doing, or at least to your skills, I think pushing that is more important than worrying so much about whether you got a B or a B- in a class or something like that. So something just to keep into consideration. And then just to address the last one, since I'm looking at them all right now, at least all the internships that I looked at and that were offered to me were paid. I wasn't aware of any unpaid ones. I'm sure there are some out there, but they will be paid most likely also. So that's my 2 cents.
Yeah, actually, final thing I wanted to say about research at Cal Poly, because we are a state school, it is harder to find projects. And so something that I would really recommend is you guys take the seminar course as early as you can. It will give you exposure to all of the resources and all of the research that's currently being done in the department. And if perhaps, let's say you don't have the skill set, but you have the interest, you can find the project that perhaps you want to do your thesis on early on. And so I'd really recommend that to all of you.
I'll jump in on that one as well. I like that comment from Sam. So being one of the professors, I very much look for anyone who's willing to jump on a project. So Sam's talking about it very much in terms of looking forward grad school and a thesis, but Cal Poly students are uniquely qualified going into even freshmen, being hands-on and learning skills and things like that, and that are in the lab, that are in a lot of the shops, becoming technically competent to build things that I have had freshmen on my research teams. I've had grad students on my research teams working side by side. And so, I highly encourage everyone, as Sam just did, that if you are, and even as all of them have, right? If you have something you're interested in, or you don't know what you're interested in, I very much encourage everybody to just jump in with both feet. Try something. If it's not your cup of tea, right? That there's no harm in giving it a try, and if you don't like it, that's fine. And everybody, all the professors are doing something that is interesting, some more than others in terms of research. But we're all looking for people who are committed and excited and just trying to learn something new. So definitely definitely give it a go. Don't be afraid to ask around and shop around. All right. I will take this as the awkward silence that signals the end of this session. So I have to thank, this is where we'd have applause for everybody. So thank you to Sam, Sylvia, Michael, and Zoe for taking their time on a Sunday to give us some great overviews and insights into their grad school career and internship opportunities. So with that, I will end the session. I encourage everybody to jump into the Q&A with the department chair, Professor Jim Widman, if you do have any further questions. If not, again, please visit and email and contact the department. We're happy to answer any questions you have. And if not, then I look forward to seeing you all here on campus at some point, fingers crossed, for fall 2020. And looking forward to having you in a number of courses. So have a great rest of your Sunday and look forward to seeing you soon.